Hello, welcome to the New Engineering channel. I am Godfrey. In our last electrical and electronic related episode, we looked at resistors. In this episode, we shall discuss capacitors, the various types, and their operation. And if possible, we shall solve a small real-life problem with it. I know you can't wait to get into this video with me, but before, please do me a favor by subscribing if you haven't done so. And please share with others so that they can also get to know about this channel. Let me also introduce you to our sponsor for today's video, Promise Special Breakfast. If you are in and around the environs of UMAT, then Promise Special Breakfast has got you covered. I'll tell you more about them at the end of the video. Thank you very much. A capacitor is a two-terminal passive electrical component that has the ability to store electrical energy in the form of charges. Here are some pictures of capacitors. Capacitance, which is the measure of the charges stored per voltage, is measured in farads. Named after the British scientist Michael Faraday. Some types of capacitors include electrolytic capacitors, ceramic capacitors, and film capacitors. Other special capacitors are mica capacitors and XY rated capacitors. Here is a picture of some capacitors used in an electric circuit. Symbols of capacitors. Now let's look at the operation of capacitors. The basic makeup of a capacitor can be seen as two plates with opposing polarities put closely to each other with a dielectric or an insulator between them. When a capacitor is charged, charges at the plates attract each other but cannot get across the dielectric. Looking at the diagram carefully, two plates with area A with distance d between them and a dielectric having a certain permittivity epsilon. The capacitance of the capacitor can be calculated using the relation C is equal to epsilon A over D, where C is the capacitance, epsilon is the permittivity, A is the area, and D is the distance between the two plates. In some special cases where the capacitor has n number of plates, then C is equal to epsilon multiplied by n minus 1 times A all over D. Note that the absolute permittivity epsilon is equal to the permittivity of free space epsilon naught multiplied by the relative permittivity epsilon r. So here is a simple problem where we are going to use capacitors to solve it. In fact, just a capacitor, only one. Considering the circuit shown, the load R is connected to a source voltage V and it should be working under normal conditions. But should there be a short interruption in the source, it will affect the load, which we don't want. So we can solve that by connecting a capacitor parallel to the load. This is what happens. When a capacitor gets connected to the source, it begins to charge until the voltage across it is equal to that of the source. Then the current stops flowing. We then connect the capacitor to the load begins to work until the voltage across the capacitor reaches 0. We should note that a capacitor cannot be a reliable source since it discharges faster than a cell. So, to have a constant flow of current to the load all the time, we can connect the capacitor to the load such that A part of the current from the source gets to the capacitor to charge it, and a part of it keeps the load working, as shown in the diagram. Here, should there be a short interruption in the source, the capacitor takes over as a source, and probably by the time the capacitor voltage will get to 0, the source will be made active again. Hence, our problem is solved. Some capacitors have some voltage value written on them. This voltage value is the maximum voltage the capacitor can handle. And finally, a piece of advice from myself. You do well not to touch the terminal of any unknown capacitor. Make sure that you are certain before you touch its terminals. But you can forgo this advice by touching the terminals of one if you see it. You only receive the best electric shock of your life, and if you are fortunate, you'll be back to tell us your experience. Thank you very much for watching this video. I believe you learned something from this video. Please subscribe if you haven't done so, and share. Thank you very much, and bye. And before I leave, do well to stay positive. And now, let's talk about Promise Special Breakfast. According to research, it is very necessary that we take breakfast every morning before we start the day's activities. But as a student like myself, with all the busy schedules, I don't get time to prepare breakfast for myself. That is why Promise Special Breakfast is here to help. Just at the comfort of your room, you order your breakfast and it will be delivered to you just right on time. You wouldn't have to worry about going to lectures with empty stomach anymore. You can call them on the numbers displayed on the screen. Promise breakfast, just as promised.